Mathematics is just more than arithmetic. It is more than calculations. As in the previous video, we talked about how mathematics is just more than calculations. It is more about understanding the concepts. It is more about making discoveries. It is making new things out of old formulas. That was mathematics. That was I talked about. Mathematics is more about understanding its concepts, and in schools we learn the concepts of mathematics, which is even 2000 years old, and much of the mathematics is which is used in the today's technological advanced world is not more than 300 years old. It is much of it less than a century old. So how did mathematics begin? Because if we know the history of mathematics, then we are more likely to appreciate how it evolved and how to approach it the right way, right? So around 10,000 years ago, it was started to used by the people for trade and money, to give and take. And over time, the civilizations of Egyptians and Babylonians took mathematics, evolved it, made new discoveries in the field of geometry and trigonometry, and they used it for construction and astronomy. And similarly, in 500 BCE, the Greek civilizations took mathematics, evolved geometry further, and they published a book which was famous, almost as famous as Bible. It was on the second demand after the Bible. It was called Euclid's Elements. It stated the theorems, which are rules that can be proven step by step or by using the idea of proving mathematical statements logically. So it became one of the most widely read books in history. Now we have to understand what is modern math, and we need to understand what is the difference between school math and modern math. Now most of the school math is based on ancient discoveries of calculus and probability theory, which were done in the 1600s, and almost nothing from the last 300 years is taught in schools, even though modern math was developed in the last 200 years. So that's why most people don't realize that math is an active field with ongoing discoveries, and they tend to think that it is only about calculations in geometry, calculus, trigonometry. It's not really like that. It is more than what you have seen. You have to remove the cloth from your face to actually see the reality of mathematics. Now if we take the example of NSA, which is National Security Agency in the United States, they employ many PhD mathematicians. They employ them for most likely to work on code breaking and cybersecurity, and the exact number of mathematicians they hire is classified. So now let's come to how the mathematics grow, how it grew, right? So if we know how it grew, then we can actually get into it branches. Like the mathematics this subject have branches. So what kind of branches? Calculus, arithmetic, geometry, trigonometry. These are called the branches of mathematics. So if we talk about the how this mathematics evolved, then in the starting of 1900s, mathematics had about 12 main subjects, such as arithmetic, calculus and trigonometry, also geometry and many more number theory. But today there are about 60 to 70 branches of mathematics, um, and some older fields like algebra and topology, they have divided into subfields. And if you talk about new areas of mathematics, they are complexity theory and dynamical systems, which have emerged. And in the 1980s, the mathematicians, which already know about modern math, so they defined mathematics in a new way. They called it the science of patterns. So this means that math is not just about numbers, but also about recognizing patterns and understanding different types of patterns. So if I talk about the general patterns which you must have already heard, so if let's talk about them. The patterns of numbers, those patterns comes under number theory and arithmetic. Now patterns of shapes comes under geometry, and patterns of motion comes under calculus, patterns of reason comes under logic, patterns of position and closeness comes under topology, patterns of natural world comes under fractal geometry. Now if you talk about probability, it is the patterns of chances. So mathematics is everywhere. It helps us understand the world, solve problems, and create new technologies. As society continues to evolve, the math will keep growing along with it. So if we know how the modern mathematics work, then we can be a solid provider in creating new technological devices, new technologies. And that's why I think everybody should actually know how the modern math works.